All right, let's get started. Today is February 16th. We are going to be continuing to practice with our quadratic functions. At this time, everyone should have their cell phones put away. If you would like to get your laptop out and answer the questions on Canvas as we go, you are welcome to do that. This assignment will be turned in on Canvas, and we will have time to complete all of it together today. So having your laptop out while we're doing so may make that easier for you to do. While the video is going, it is just like I am teaching. So the same rule for headphones apply. There should be no headphones or earbuds in while I'm teaching and the video is going. When the video's over and you're submitting your work, you're welcome to listen to your music as long as it is not disrupting everyone else. Okay. So as y'all are putting away your cell phones and gathering all the things that you need, some important information. I'm not going to be here tomorrow, so there will be another video for tomorrow as well. On Monday, there is no school, so I will not see you on Monday either. So let's go ahead and get started. Today, we're going to be identifying key attributes of quadratic functions, including their domain and range, like we talked about yesterday. Okay. You should be able to do majority of the first part together. So we're going to start with a 5-minute timer where you should be working on the first set of questions. Okay. As you're working through these problems, underline the key word. You are welcome to work with your partner, but you should be completing the first 6 problems on your own. Everyone should be working, and everyone should be putting this in on Canvas as we go. It will make your life a lot easier. You have about 1 minute left. If you have finished those problems, you can kind of look through some of the other ones to see if you know how to do those as well. All right, let's go ahead and take a look at number 1. Number 1 says find the x-intercepts. So the first thing that I'm going to do is look for my keyword. So everyone should have underlined the word x-intercept. Okay. X-intercept is just referring to where the graph crosses the x-axis. And so as we're looking here, I see that my graph crosses right here and right here. When I look at my answer choices, I notice that they are written as ordered pairs. So it's not just 0 and 2. Instead, they're written as an ordered pair. Since it is an x-intercept, I know that my value should be written where the x goes, and the y value should be a 0. So for this first point here, my x value is 0, so that makes it 0, 0. And for my second point, here we have a 2, so I'm going to put a 2 in for x, and it would be 2, 0. So that would make D my best answer. Looking at number 2, find the axis of symmetry. My keyword is axis of symmetry. What does axis of symmetry mean? What does it mean for things to be symmetric? Symmetry just means that you can fold your graph in half and it would be the same on both sides. When we see the word axis of symmetry, we know that that's all about the x's. So the first thing I'm going to do is take a look at my answer choices and get rid of anything that doesn't say x equals. So answer choice A, I know will not be correct because axis of symmetry is all about the x's and it says y. Same thing with answer choice D. Answer choice D will not be correct because it has to be an x equals equation. And it's equal to the x value of our vertex. Or when you draw the axis of symmetry, it's where that line crosses the x-axis. So for this problem, we would have x is equal to 1. Taking a look at number 3. Number 3 says find the minimum. Our key word is minimum. What does minimum mean? Minimum is the lowest point on our graph. Remember, a graph will have a minimum or a maximum, but not both. A graph that looks like this, a U-shaped graph that is smiling, has a low point. It's right here found at the vertex. That is its minimum point. But remember, to measure the minimum, we always measure to the wall like we're measuring height. So we're always going to use that y value for the minimum. So the minimum value for this graph is -1. Number 4. Number 4 says find the vertex. Our keyword is vertex. Vertex is the MVP of quadratics. There's a lot of important things that happen at the vertex. But when we're talking about the vertex itself, we're talking about this exact point in which the graph changes directions. And since it's a point, it needs to be written as an ordered pair. Okay, so when I want to write that point, I take a look at the x value is 3 and the y value is -2. When you go to write that ordered pair, just like in your ABCs, make sure that your x value comes first. So it's going to be 3, comma, -2. That makes C my best answer. Number 5. Number 5 is a little bit tricky. Number 5 asks us for the y-intercept. Originally, we think that that's easy. Y-intercept is just where the graph crosses the y-axis. But I'm looking here at my y-axis, and I notice that my graph doesn't actually cross that line. Well, as I'm looking at my answer choices, I notice a few things. A and B look very similar. One says -12, 0. The other one says 0, -12. Well, I know that if it is a y-intercept, it has to have the number where the y goes, and the x value should be 0. So by knowing that, I know that A cannot be it, and C cannot be it, because those have values for the x value instead of the y. So now that I'm down between just B and C, what we're going to do is called an estimation. We're going to estimate or hypothesize where we think this graph is going to cross the y-axis, because I don't actually see it crossing it anywhere. Okay, I notice that my graph is opening downward. And so as it continues to open downward, I know that it's going to open up wider. So I'm going to assume that it's going to cross somewhere down here off the screen or off the chart from what we can see. Okay, well, when I look at my answer choice B says -12. -12 is somewhere down here, right about where I thought that it would cross. So B is looking like a pretty good answer. But since it's an estimate, I want to go ahead and check the other ones as well. D says -3. Well, -3 is up here. That's definitely not the y-intercept. So I know that B has to be correct. So we're using estimation tools, and we were also using process of elimination by knowing that for a y-intercept, the value has to be in the y. Let's take a look at number 6. Number 6 asks us to find the vertex. Once again, my keyword is vertex. So I'm looking at the point where the graph changes directions. It's where it stops going down and starts going up. When I write the vertex, it needs to be written as an ordered pair. So I'm looking for the x value and the y value. The x value of this point is -2. And the y value of this point is -3. So when we write that as the ordered pair, it's going to be -2, comma, -3. Putting the -2 in for x and the -3 in for y, making D our best answer. Okay, so hopefully you were able to answer all of those. Let's go ahead and move on to number 7. Number 7 is asking me for the maximum. So it's not any different than some of those problems that we were doing earlier. The only issue is I don't have a graph to look at. So if I don't have a graph to look at, the easiest thing for me to do is to use my calculator and graph it. So if you don't have a calculator, you need to make sure you have one at this time. So go get yourself a calculator. As they're getting their calculators, or as you're grabbing your calculator, go ahead and watch up here to see the easiest way to solve this. I know that I want to look at it in a graph because that's the easiest way for me to find maximum. But even if I didn't, the y equals here is a telltale sign. Anytime we see y equals, we should try to graph that equation. So everything after that equal sign is going to go straight into my calculator. So I'm going to open up my calculator and add a graph. Minus 5x squared, remember we only use the minus sign, plus 10x plus 4. When I hit enter, as I want to find a specific point, I'm going to use menu 5-1. I'm going to trace around, and it tells me that the maximum value is the ordered pair 1, 9. Well, for maximum values, we only want the y value. Okay, so the maximum point, the highest point of this graph is 9. If you were to look on your calculator, if you measure it to the wall, you're measuring it to the 9 here. Or once again, it's the y value of your vertex. Okay, so at this time, I would like for you to go ahead and complete numbers 8 and 9. You're going to need to use your calculator. So graph the equation and use menu 5-1 to trace it and find your key piece. Don't forget that as you graph it, when you use menu 5-1 and start moving side to side, a yellow box should pop up anytime you find a key attribute. Everybody should have a calculator in their hand, and everyone should be graphing this problem. We're looking at numbers 8 and 9. Got about a minute left. All right, time is up. Let's go ahead and take a look at those together. Number 8. Number 8 is asking me for the y-intercept. If you're looking at the equation and you know that the c value is the y-intercept, you could go ahead and answer this. Or if you notice that it said f of x, you immediately think to graph it. Or just knowing that you're looking for the y-intercept, you know that graphing it is the easiest way to do that, just by kind of getting a good visual. So we're going to go in and add our graph. Minus 3x squared plus 5x minus 2. When I graph that, I'm going to use menu 5-1 to trace my graph. My graph always starts at the y-intercept, but if you weren't sure, you could go back and forth and you see that that yellow box pops up telling you that your y-intercept is 0, -2. Now, when it's written as a griddable like this, they do not want you to put it in as an ordered pair. They just want the value itself of -2. So make sure that your negative sign goes in the front box where the plus or minus goes. And then we're going to put our 2 here. It can either be right next to it or it could be at the very end. It doesn't really matter where the 2 goes. It only matters that you have the negative sign in the correct spot. All right, well, let's go ahead and move on to number 9. Number 9 says find the minimum. The key word is minimum. So I'm looking for a graph that has a low point. When I notice that f of x, I'm going to go ahead and just graph that right into my calculator. I'm going to type it in exactly how it looks. 3x squared plus 6x plus 1. I notice that I have a graph that has a low point. I'm going to use menu 5-1 to be able to trace my graph. It starts me at my y-intercept, and I want to move to the left to find the minimum value here. So as I scroll to the side to the left, a yellow box pops up and says minimum. It's saying, hey, here's the point you're looking for. Don't forget that the minimum value, we always measure it to the wall. So we're always looking for its y value. Its y value is -2. Remember, the negative sign has to go in the very front box, but the 2 can go anywhere you want. So this one, I put it at the very end. That's okay, as long as the negative sign is where it belongs. Okay, let's take a look at the next problem, number 10. Number 10 is giving us a table, and it wants us to find the vertex, the axis of symmetry, the zeros, and the y-intercept. Okay, this one's a little bit more tricky because I don't actually get to look at it. If you would like to try to graph this, you're welcome to do that. That is a helpful way to get a visual on it. But if you remember the first day that we started talking about quadratics, we talked about how it looked in a table. And really what we're looking for is that center point of the table. Remember, our vertex has that middle point where the axis of symmetry is going to start doing the same thing on both sides. So an easy way to find that in the table is to look at your y values. Look at your y values here. We have 0, -3, -4, -3, and 0. There's a type of pattern. It's really a reflective pattern. If you notice, the -4 is trapped in between these two -3s. Okay. Remember, we talked about Jackson being girl trapped at the restaurants when we used to sit down. If there was 2 girls on either side of him, he'd say, oh no, I'm girl trapped. Well, that's what we're looking for. We're looking for the number that is trapped by the same number on both sides. It's kind of like a sandwich. So this looks like a sandwich where -3 and -3 are the bread, and the -4 is the meat in the middle. And that meat in the middle is our vertex. So our vertex for this problem is -1, -4. And we're just going to write that as the ordered pair, -1, -4. Now that you know your vertex, it's easy enough to do the axis of symmetry. Axis of symmetry, remember, is all about the x's. It's going to be an x equals equation equal to the x value of your vertex. So we're going to use the -1 here. And my axis of symmetry is now x equals -1. Make sure that when you do this, you write it as the equation x equals -1. You cannot just put the -1 there. They will also try to trick you by making it say y equals -1. Axis of symmetry is all about the x's. Make sure it's an x equals equation. The next question is asking me for my zeros. What does zeros mean? Zeros are just the x-intercept. Okay, so we're looking for where the graph crosses the x-axis. When we're looking for a table, what that means is I want to know what the x value is when y is 0. Remember, there should be 2 of these points unless my vertex is a 0. If my vertex is a 0, there will just be 1. But my vertex was -1, -4. That is not one of the zeros. So I'm looking for 2 things where what is the value for x when the value for y is 0? Well, I see that I have one right here at the top, and I see that I have another one here at the bottom. So the value for x is -3 and 1. So when you write that, sometimes they want it as an ordered pair. So you can write that easy enough from your table. -3, 0 and 1, 0, where we have the value in for x and a 0 in for y. The next question is asking us for our y-intercept. Well, that's the same thing. It's where the graph crosses the y-axis. Well, when you look at that as an ordered pair, it's what's the value for y when x is 0. Well, I'm given that on my table right here too. It says 0, -3. I'm going to give you 2 minutes to go ahead and look at the next one and try to see how much you can figure out on that one. This one's a little bit tricky because even though there are some pieces, they may not be easy to find on the table. You may have, here's a hint, you may have to extend the table out. You are welcome to try to work this one with your partner and figure out how you should extend that table to be able to find all of your answers. Everyone should be working with their partner on number 11. Got a little less than a minute left. All right, time is up. Let's go ahead and take a look at that together. The first question is asking me for the vertex. So that's the middle point where my graph starts to change directions. I'm looking at the y values to see where I notice the pattern starting over. Where's the middle of that pattern? Where's my sandwich? Well, I see that right here where I have a -9 that is trapped in between 2 -8s. So that makes the -9 the very center of my table. And that makes the ordered pair -1, -9 my vertex. For the axis of symmetry, now that I know my vertex, the axis of symmetry is really easy. Axis of symmetry is all about the x's. It should be an x equals equation equal to the x value of my vertex. So it should be x is equal to -1. For my zeros, zeros are what is your x value when y is 0? Well, I notice that I have one of them, but I'm missing the one on the other side, okay? If this one is down here, there's got to be another one on this side of the vertex. So we're going to extend this table at the top to go and find our other 0. And we can do that by just like creating a pattern. If you notice on your x-axis, we're going 2, 1, 0, -1, -2. The next one would be -3. When I'm trying to figure out what its y value is, keep in mind that the axis of symmetry runs through -1, -9. So whatever's on one side, the same thing has to be on the other. So since I have a -8 here, I'm going to have another -8 here. Well, after the -8, we have a -5. So after this -8, I should have another -5. Okay. Well, that didn't get me to the 0, but it got me one step closer. Okay. So as I continue the pattern for the x's, after -3, it becomes -4. Well, if I continue my pattern here, it went -8, -5. The next one is 0. So now I have found my second 0. So I have a 0 of -4, 0 and 2, 0. Remember, sometimes you're just going to list them out. Sometimes you're going to write them as an ordered pair. When you write them as an ordered pair, make sure your x value is in the spot for the x. Okay, lastly, we want to look at the y-intercept. The y-intercept is just what is y when x is 0. Well, that was on my given table right here. And that's 0, -8. Okay, so that's how you can find the key pieces on a table. All right, so let's take a look at number 12. Number 12 says, what is the domain and range of a function shown? Well, when we're looking at an equation, if it says f of x, the easiest thing for me to do is to go in and graph that. So I'm going to go in and add a graph. I want to make sure that I type it in exactly how it looks on my problem. So I'm going to say control divide 1/2, go to the side to type in x squared, minus 4x plus 3. When it looks exactly like my problem looks, I hit enter. I get this nice looking parabola here. If you want to zoom out a little bit to get a better look, you can use menu 4. It asks you if you want to center the graph. It's starting on its x-axis going from -10 to 10. As I zoom out, now I'm at -20 to 20. I see that that graph is still going. So that's something that we want to keep in mind. When we're looking for domain, what letter does domain talk about? Domain is x. So we're going to look here at our x-axis. I would really like to slide along this x-axis and crop this side of the graph and then go and crop this side of the graph. But the thing is I know that that graph is going to continue to go. And as I look at quadratics, as they continue to go, they're going to continue to get wider and wider as they go. So anytime I graph a function inside of my calculator, I know that my domain should be all real numbers. So immediately I'm marking off answer choice B. For range, range means our y values. So I'm looking here at the y-axis. All of my answers say f of x, which is the same thing as y. So I just need to figure out where I can crop this picture. I can crop it here at the bottom, but I cannot crop it at the top because the top is going to keep going. So I cropped it down here at the bottom at -5. And so that allowed me to mark out answer choice D because it says we're using the 4. We want to make sure that since we're talking about range, we're sticking with the y value of -5. Now, I want all of the numbers above that line because my graph lives above that line. So above, would that be greater than or less than? Absolutely. Above is greater than. So that makes A my best answer. Let's take a look at number 13. Number 13 does it a little bit different. It says, which graph best represents a function with a range of all real numbers greater than or equal to -6? It gave us the range, and we have to pick the graph that goes along with it. We'll take it piece by piece. Range means y. So we're going to look at our y-axis. We want it to be greater than or equal to -6. So on my y-axis, I'm just going to go to -6 and see what it would look like to crop that picture at -6. When I look at those 4 crops, the first thing I notice is that is not a good crop for answer choice A. There's still a lot of space right here. It's also not a good crop for answer choice D because it cuts that graph in half. So now I'm between C and B. And since it says greater than, I want the numbers above that line. So that makes C my best answer choice. All right, last question. Last question says, which graph best represents a quadratic function that has only one zero? What is our key word? What is our vocabulary word in that problem? Something we've been labeling this whole time. Absolutely, zero. What does zero mean? Zero means x-intercept. So let's take a look at these x-axes. I'm looking for where these graphs cross on this x-axis. More specifically, I'm looking for a quadratic function that has only one zero. So it's only going to cross the x-axis or touch the x-axis one time. When I look at answer choice A, it has 2 zeros. When I look at answer choice C, it has 2 zeros. So no, that's not good either. When I look at answer choice B, there's only 1 zero. And if I look at answer choice D, it doesn't touch the x-axis at all. So that would be an example of no zeros. So the best answer for number 14 would be B. All right. Once again, make sure that this is turned in on Canvas. That's the only way you're going to get credit for today. Make sure you get this submitted on Canvas.